Thanks, folks. It's our pleasure to bring to you today a brief talk about our journey in implementing policy as code for the Google Cloud platform. My name is Anton Pleshakov. I'm part of the Goldman Sachs security architecture team in the New York office. Joining me today are Katie from Deloitte and Navaneeth from the Tech Risk Engineering Dallas office. Together, we've been collaborating with Google to develop an approach to policy as code that we hope you'll find interesting in your own endeavors. Today, we'll be talking to you about why we need Gatekeeper and IAC, what these two tools accomplish together. We'll also cover how we've developed policies for these tools, and we'll show you our integration journey and some of the additional challenges that we faced when trying to implement this approach. As many of you know, infrastructure as code is a way of deploying resources through code instead of pressing buttons on a UI. And Gatekeeper is a policy engine that can look at your code and evaluate it for misconfigurations. So broadly speaking, there are two categories of capabilities we're interested in. The first are preventative controls. This is Gatekeeper's ability to block the deployment of misconfigured resources, and also the ability to block usage of unapproved resources and services in their entirety. And second, it can function as a detective control. So it can report violations for attempted resource deployments, and it can also be used as an on-demand scanner against your assets to get a point-in-time assessment of their configuration. Why do we need Gatekeeper and IAC? IAC gives us the ability to shift left in our approach to infrastructure security. It allows us to bring controls closer to the SDLC process and place them directly in the hands of our developers. It also allows us to create patterns that can standardize the deployment and configuration of resources without developers or security teams having to explicitly worry about it for every single resource that gets deployed. Modern cloud environments grow very quickly and resources come up and down every day. So having an automated means of assessing them is crucial to a long-term cloud strategy. Gatekeeper itself ensures that only approved resources and their configurations actually arrive into our production environment, and they can report violations to developers, service owners, or security teams. Next, I'm going to hand it off to Katie to talk about our policy development process.
Thanks, Anton. When we first began our journey with policy as code, we first reviewed the Google Cloud native services that we knew were being prioritized for use in production. We explored each service by, one, determining the available configurations for the service by looking through the documentation and exploring within the console itself, determine what threats and risks could be posed when certain configurations were in place, and define what policies to mitigate those risks. Once we decided on the policy language, we created these policies using Gatekeeper constraints and templates. To test these policies, we created two separate config connector deployment files per policy. One creating a resource that should be allowed, and the other creating a resource that should be denied. We deployed the policy to policy controller, attempted to deploy the test resources to the testing environment, and compared the results with our predicted outcomes. After we confirmed the policies were working as expected, we were then ready to deploy the policies for that service. So next we'll go over a sample policy that requires that every BigQuery table is protected with a customer managed encryption key, or CMEK. Here's a sample template for this policy. So at the top, you can see that we've designated it as a constraint template. We've given it a unique name and kind that describes the policy, and we include rego language that looks for mention of a name of a key in the deployment file. If we can't find the name of a key within the deployment file, we know that a CMEK wasn't included, and we display the violation message, which shows which BigQuery table is causing this violation and does not include a CMEK. Here's the sample constraint for this policy. Here we specify the kind of the template that we just created so that we know to apply this constraint to that template. We set the enforcement action to deny the deployment of non-compliant resources, and we designate that we want to enforce this policy on all BigQuery tables. Next, Navaneeth will describe how we were able to build upon Google's out-of-box solutions to shift even further left.
Thank you, Katie. Hey, I'm Navaneeth. I'm a vice president with Goldman Sachs, and I run the secure SDLC engineering function for the firm. we innovate, we build, we improvise our technology solutions to secure our firm. And in doing so, developer experience is an integral and important part of every solution that we build. Right now, I'm going to take us all through the journey, how we have this gatekeeper playing a security guardrail function in the new design. We have seen so far where Katie and Anton have been walking us through how gatekeeper can be used as an effective security guardrail. The initial design suggested has gatekeeper running as an admission controller in the KCC cluster. This enables to enforce the policies at the deployment stage. When any resources are being deployed to the GCP environment, at that time is when the security enforcement is happening. Now we are presented with a couple of challenges with this design. The first one being to provide early feedback to the developers. Now look at it. If we are enforcing security constraints only at the time of deployment, the developers are not aware at the time of their development. So we wanted to address that. The second challenge is at times the cluster becomes unstable due to repeated failures at the deploy time. We wanted to solve both of these challenges, and we went back to the drawing board along with the Google Cloud team, and we came up with this new design where we shift left the gatekeeper solution. So what did we do? We picked the gatekeeper enforcement engine out of the deployment stage and we bundled it in the CI stage. So that provides an early feedback to the developers, and it also solves the cluster instability issues because at the CI, we have not even deployed anything yet. So that's how we solved this. Now let's do a deep dive into this design to understand this better. Now consider these two repositories here. The first one is a policy repository where all the gatekeeper policies will be maintained by the security analysts. This will be a central repository where all the policies are maintained, and it will be authored by the security analysts who have the best knowledge on writing those. And then for our consideration, we have another sample repository. Let's consider it just source code repository. This is similar to any application team's development repository. Now, when a developer is making changes to the source code repository, a pipeline will be triggered. And as part of that pipeline, we are introducing a new job, which is going to be the new effective security guardrail. And this new job has 4 stages, namely lint, prepare, validate, and report. The first stage, which is the lint stage, provides us the ability to perform checks for any syntax errors or any config sync errors. We can do this by utilizing tools like kubeeval and nomosvet for this purpose. The second stage is the prepare stage, and this involves 2 aspects. The first one is to pull the security policies which are defined in the policy repository. We would pull all those security policies into this prepare stage so that they can be used in this pipeline job. The second aspect is what we call as exception management. Now let's spend a minute to understand what is exception management. The security policies are created to enforce security guardrails. In certain business scenarios, some business products may have a requirement to override these security policies in a way they want to be exempted from them. And there exists a separate security review process to vet if a business need is applicable for such exceptions. Those needs to be centrally maintained in an exception management platform. We, in this prepare stage, can integrate into those centrally managed exception platform and pull those approved exceptions also into this. So our prepare stage now will have the list of security policies that needs to be applied, and if a business has any exception, that detail is also fetched. Let's move to the third stage, which is the validate stage. The validate stage is going to execute the gatekeeper validate function, which is the key aspect of enabling the security guardrail. From the previous stage, the policy details of which needs to be enforced are fed in along with the exceptions, and the gatekeeper validate will now execute this entire policies on the resource that the developer has developed. And the results are then fed into the fourth stage, which is the report stage. And in the report stage, an immediate feedback to the developers are provided in the pipeline. In addition to that, this stage also has the ability to integrate to any centrally managed findings platform. Now, why do we need a centrally managed findings platform? In some cases, as the developers write their code and if some security violations are identified, we may want to immediately address them, so they need not require a separate finding management platform. But in certain situations, if you remember, we touched upon the business requiring exceptions. In those cases, we need to report them in a central platform so a security team can review and assess if an exception is required. So to facilitate that, the report stage will also have ability to downstream the results into the centrally managed platform. With all these four stages put together is our one containerized job, which will be deployed in the pipeline, thereby enabling an effective security guardrail by shifting left with the gatekeeper. So as a next step from here, we are exploring how to make these solutions available for public usage. For instance, the security policies which we have authored, we are looking at to make it available for the community. In a similar way, the containerized image of the pipeline job that we created to have Gatekeeper running in a CI stage, that also we are looking at ways to make it available for the community. And with this, we come to the close of sharing our journey of how we shift left with Gatekeeper to address a security guideline requirement.
Thank you to Anton and Navaneeth and Goldman Sachs for joining us, and feel free to reach out with any questions.